the spinning of the earth around its own axis, which is an imaginary axis. Let us learn rotation and revolution of the earth and its effects. The spinning of the earth around its own axis, which is an imaginary axis, is known as rotation of the earth. Now this axis is tilted at an angle of 23 and a half from the vertical. And with this tilted axis, the earth revolves around the sun, and that is known as revolution. So these are the two important motions of the earth, that is rotation and revolution. The axis of the earth is an imaginary line passing through the center of the earth as it does on the globe. The two endpoints through which the axis passes is known as North Pole and South Pole. The axis is tilted at an angle of 23 and a half from the vertical. This means that if a line were drawn parallel to the plane of the Earth's orbit, the Earth would make an angle of 66 and a half degrees to this line. Now let us understand the characteristics of rotation. The first one is direction. The Earth completes one rotation from west to east on its axis in 23 hours, 56 minutes and 4.09 seconds, which roughly comes to 24 hours. Then it is inclination of the axis of the earth. The earth is always tilted in the same direction. That is, it is pointing towards pole star. That is, its north pole is pointing towards pole star as it is moving around the sun. Third is the speed of the Earth's rotation. The speed of the Earth's rotation at the equator is 1670 kilometers per hour, because the circumference of the Earth is 40,070 kilometers. So at the equator, the Earth would be traveling 40,070 kilometers and it is covered in 24 hours. So in 1 hour, the Earth rotates 1670 kilometers per hour. So if we sum up the characteristics of rotation of the Earth, it is the Earth completes one rotation from west to east on its axis in 23 hours, 56 minutes, 4.09 seconds. That is roughly 24 hours. The Earth is always tilted in the same direction as it is moving around the sun, and the speed of the Earth's rotation at the equator is 1670 kilometers per hour. Now let us learn the effects of rotation. The first and the important effect is the day and night are caused by the rotation of the Earth on its axis. This is because a part of the earth faces the sun and it has day, and the other part which does not face the sun has night. And this happens with precision and progression and not suddenly. So I will say this happens accurately and gradually. It does not happen suddenly. The time when the sun begins to cast its light in the morning is known as dawn. At noon, the sun is overhead. At dusk, that is in the evening, we see the twilight. Twilight is the light that we see after the sun sets. So here, the sun is disappearing in the sky. At night, we all know it is so beautiful and completely dark. The duration of the day and night is not equal at all the places on the earth. This is because of the inclined axis of the earth. If you look at the important latitudes on the earth, it is equator, Tropic of Cancer, Tropic of Capricorn, Arctic Circle and the Antarctic Circle. Now if you see the lines carefully, in the southern hemisphere, you will understand that the duration of night is longer, and in the northern hemisphere, the duration of day is longer than the night. The reason is the northern hemisphere is facing the sun and the southern hemisphere is facing away from the sun. But if you look at the Arctic Circle and Antarctic Circle, the Arctic Circle is completely in day. So when the Earth is rotating, the entire region beyond the Arctic Circle will have day. There the sun will not set. Whereas in the southern hemisphere, beyond the Antarctic Circle, you will see it is completely dark. And here the sun will not rise. The length of the day varies with respect to even seasons as well as latitudes. So the length of the day varies with respect to latitude but also seasons, and we shall be learning about them gradually. Then it is the sunrise and the sunset. This happens because of rotation of the earth. Then it is the Coriolis effect. Now we all know that the earth is spinning at a great speed. At the equator it is 1670 kilometers per hour. Second, we have learned that because of the spherical nature of the earth, different part of the earth receives different amount of sunlight. So there is difference in temperature at different places. Because there is difference in temperature, there will be difference in pressure. Some places will have a high pressure and some other place will have a low pressure. And because of that, the wind moves. The wind always moves from a high pressure area towards low pressure area. Now when the wind is moving on the surface of the earth, the wind bends. The wind bends because the earth is rotating at a great speed. In the southern hemisphere, the wind will bend towards left, and in the northern hemisphere, the wind bends towards right. Now when you look at these arrows, it is very clear that they are bending towards left. But when you are looking at these arrows, it will appear as if they are also bending towards left. But for the arrows in the south, you will be looking from the southern end. Similarly, for the arrows in the northern hemisphere, you have to look at it from the northern end. Then you will see that they are actually bending towards right. So the wind in the northern hemisphere always bends towards right, and in the southern hemisphere they bend towards left. But in the equatorial region, that is region between 5 degree north and 5 degrees south, the wind does not bend. These are the regions of doldrum, or we say these are the regions of calm, and these are the regions of low pressure. The next important phenomena that we see is the sun, the moon and the stars seems to move from east to west. Now you may say that you have seen sun moving from east to west. What about the moon and the stars? But actually if you see in time lapse, you will understand that they all are moving from east to west. This is because the earth is spinning from west to east. Now this effect is similar to what one experiences while sitting in a train and looking out of the window. What do we see? We see the trees and buildings and everything moving in the opposite direction to that of the train. The reason is the train is moving at a very great speed. The same happens with the earth. When you look at the sky, it appears as if the sun, moon and the stars are moving, but actually the earth is spinning on its imaginary axis. Then the earth also generates centrifugal force. Centrifugal force is the force that is generated from the center towards the periphery, that is towards the edges. This is because the earth is spinning at a very great speed. It is the same effect that we see every day in our kitchen when we are operating a mixer. All the chutney will come and stick on the edges of the glass. And this is the reason that along the equator there is a bulge in the earth, and the earth is said to be geode shape. Then rotation also causes difference in time, because when the earth is spinning, some part of the earth has day and some other part has night. Some part of the earth there is sunrise happening, and somewhere else the sun is setting. So different part of the earth will have different time. Then the short rotational period makes the variation of temperature between day as well as night moderate. So neither day nor night is extreme, it is moderate. The rotation and revolution also causes seasons and variation in the length of day and night, and we are soon going to learn that. So let us summarize the effects of rotation. The effects of rotation are occurrence of day and night, sunrise and sunset, Coriolis effect. The sun, moon and the stars seem to move from east to west. Centrifugal force, rotation, and we have seen rotation causes difference in time. And the last one is the site of the earth. Now we have seen that the earth is spinning around its own axis, and this axis is tilted. With this tilted axis, when the earth revolves around the sun in an elliptical orbit, that is the orbit that appears like an ellipse. Ellipse means an elongated circle. So when the earth is revolving around the sun in an elliptical orbit, we call it as revolution of the earth, and this leads to various phenomena. The earth moves at an average speed of 29.8 kilometers per second, or it is easy to remember 1 lakh kilometers per hour. So earth is spinning at a speed of 1670 kilometers per hour, and the earth is revolving around the sun in an elliptical orbit at a speed of 1 lakh kilometers per hour. Now if we see the revolution, the sun is not exactly in the center of the ellipse. Because it is not at the center of the ellipse, the earth, when it is revolving around the sun, there are times when it is closer to the sun, and there are times when it is far away from the sun. When the earth comes closer to the sun, that time the speed of revolution around the sun increases. And when the earth is away from the sun, the speed of revolution reduces. This is mainly because of the gravitational force of the sun. Now, the earth completes one revolution around the sun in 365 days, 5 hours, 48 minutes and 45.51 seconds. But we roughly take it as 365 days and 6 hours. Now to adjust this 6 hours, we have the concept of leap year. And leap year comes once in 4 years. So on the 4th year, February, instead of 28 days, we have 29 days. And in this way, we adjust this 6 hours. Let us learn the effects of revolution of the earth. The first effect is the seasonal changes. Because of the revolution of the earth, we have in the first phase summer. In the second phase, rains. In the third phase, it is retreating monsoon. And in the fourth phase, it is winter. Now, how does this happen? Suppose we take these 4 positions of the earth. In the first position, the date is 21st of March. In the second position, it is 21st of June. In the third position, it is 23rd September. And the fourth position, it is 22nd December. When the earth is in the second position, if you look carefully, the northern hemisphere is facing the sun. And when the earth is in the fourth position, the southern hemisphere is facing the sun. But when the earth is in the first position or in the third position, none of the poles are facing the sun. So the inclination of the earth's axis does not have any impact on the sun rays that it receives. So on 21st of March, vertical rays of the sun falls on the equator and the entire earth has equal day and equal night. But as it is moving from the first position to the second position, slowly the northern hemisphere tilts towards the sun. So in the northern hemisphere, the days become longer and the nights become shorter. And this gives rise to summer conditions, and we say in this phase it is summer in India. On 21st of June, the vertical rays of the sun falls on the Tropic of Cancer. This is the maximum inclination of the Earth's axis of the northern hemisphere towards the sun, and this is referred to as summer solstice. As we come to the third position, once again the day and night are equal, and in this phase India experiences rain. When the earth comes to the third position, entire earth has equal day and equal night. And as we come to the fourth position, the date is 22nd December. The southern hemisphere is facing the sun, and the vertical rays of the sun falls on the Tropic of Capricorn. And this is the time the northern hemisphere experiences winter solstice. So the first and the third positions are referred to as equinox because it is equal day and equal night. The first position is referred to as spring equinox, and the third position is referred to as autumn equinox. Then, as the earth is revolving around the sun, there are times when the earth is closest to the sun, and this position is called perihelion. And when it is furthest from the sun, it is called as ephelion. When it is closest, that time the distance is 147.3 million kilometers. And when it is furthest, that time the distance is 152 million kilometers. The minimum distance of the earth from the sun is reached on January 3rd, and the maximum distance that is furthest from the sun, the date is 4th July. So ephelion happens on 4th July and perihelion on 3rd January. Next effect of the revolution is the creation of heat zones. The entire earth can be divided into heat zones like the torrid zone, which lies between 23.5 degrees north and 23.5 degrees south. This region is referred to as torrid zone or the tropical zone. Beyond 23.5 degrees north as well as south, up to 66.5 degrees, the region is temperate zone. Beyond 66.5 degrees in north and south, it is the frigid zone. So there are creation of heat zones. This again is because of revolution of the earth. So if we sum up the effects of revolution, it is first one, the seasonal changes, inclination of axis and the seasonal changes, perihelion and ephelion positions, and creation of heat zones. Thank you.